All right, here we go. Law of sines, part 3. Don't worry, section 8.2 is not nearly as tricky as 8.1. We're going to get the hard stuff out of the way first. So last time, we looked at case 1. And that was when we know two angles in one side. So we know the included side, or maybe two angles in the non-included side. Easiest case. Always one solution. All right, case 2 is when we know two sides in a non-included angle, or the non-included angle in two sides. And I know it's really super corny, but it helps remember it. I say, don't let this is a tough case, it's the hardest case. Don't let this case make an ass out of you. When we know two sides in one angle and the angle is not included, we have 3 possibilities. We saw last time that there's no solution, or you may have just one solution, or we may have 2 triangles that satisfy the given criteria. So we looked at this one last time in part 2. Let's look at these 2 examples. All right, so I'm going to look at basically the same triangle. Remember last time the problem was we knew that this was 46 degrees, so this was shooting off at this angle. This had a length of 20, and then this was a side of 2, and no matter if we swung that and moved that up and down like this, it's never, ever, ever going to be able to reach this other side. So there's no angle here and no side here that would ever make those 2 connect, because this angle is stuck at 46 degrees. And when you do the law of sines and you take the inverse sine of the known ratio, you're going to get an error in your domain because the known ratio will be greater than 1. All right, so let's do this example right here. Let's solve it. This time, this side was 2 previously. I extended it to 19. Excuse my little mistake there, my sloppy triangle. All right, so here we know a side and the side and the angle opposite of it. So we know we can use the law of sines. I'm going to call this A. This will be little a. We'll call this little b, angle B. This will be angle C and little c. And we're going to solve this triangle. Now, again, I know the side. I don't know the angle, so I'm going to put my sines on top just for simplicity with the algebra. The sine of 46 over 19 is going to be the sine of B over 20, which is going to be the sine of C over C. So now we can't use these 2 together because we would have 1 equation and 2 unknowns. If we use these 2 together, we'd have 1 equation and 3 unknowns. So the only thing we can solve right here for is angle B. So knowing the sine of 46 degrees over 19 is equal to the sine of B over 20, we can multiply both sides by 20. We get 20 sine of 46. So we're in the same boat we were last time, although we now have 19 on the denominator, which is going to be which is much larger than 2, and the result is going to be that hopefully this number is smaller than 1. So then we can find an angle whose sine has that value. So 20 sine 46 degrees over 19 equals the sine of B. So the sine of B, I like doing it this way, is equal to 20 sine 46 all over 19. And I'm just going to take 20. I'm going to multiply that out. I'm going to do, let's clear that, 20 times the sine of 46 degrees. And I get 14.38, and I can know that if I could divide that by a number bigger than 14, it's going to be a number less than 1. So it's about 0.76. So seeing 0.76, this is a value less than 1. I know there is an angle whose sine is 0.746. So angle B is going to be the inverse sine of this ratio. So I'm not going to use 0.76. I'm going to use all the digits in my calculator. So the little a and s above your negative key is super helpful. So I'm going to do the inverse sine, and instead of typing all those in, I'm going to hit second answer. And when answer appears inside of a function, what it's doing is it's replacing a and s with your previous answer. So close my parenthesis, and I'm going to do this. It's telling me that angle B is about 49.2 degrees. So angle B is about 49.2180 degrees. Don't forget your little degree symbol. We are not in radians, and that's really super important. All right, so then you're going to say, all right, well, from here, can't we just put that in there and find angle C? Now, here's the tricky part. You always have to do this when you have an ASS triangle. Always. Is there another angle, let's call it, let's say B prime, such that the sine of B prime is about equal to 0.76. So remember, the inverse sine only gives us an angle in quadrant 1 or quadrant 4. But there is another angle that could possibly be inside of the triangle. So what this just gave us was about 49 degrees right here. So we just got B to be 49.2 degrees, and I'm just rounding that for simplicity. But this is another angle whose sine is also, so this is one angle. This angle also has sine equal to 0.76, where the reference angle is 49.2. So this angle right here would be 180 minus 49.2 degrees, and that's going to give me 180 minus 49.2 degrees, 130.8 degrees. So remember, we were solving this problem right here. We're looking for an angle whose sine is 0.76. So if I take my calculator and I just take the sine of 49.2, I get 0.76-ish, right? But notice if I take the sine of 130.8, the answer is also 0.76-ish. So there are actually two angles, one in quadrant 1 and one in quadrant 2. So therefore, angle B could equal about 49.2 degrees, or angle B could equal 130.8 degrees. Now it can't equal both of these. Angle B is this angle right here, and don't go by my drawing, but it may be 49 degrees. It may be 130.8 degrees. So how do we know which one it is, or could it be both? So again, when you do this, you set it up. Last time when we took the inverse sine of B, we got something that didn't exist. When you take the inverse sine, if you get an answer for an angle, you have to look for the other angle in quadrant 2 who has the same sine. And the angle in quadrant 2 that has the same sine as the angle that was given to you by your calculator is the one that has that same angle as a reference angle. So now we have to look at both scenarios. We have to look at what happens, what if angle B is equal to 49.2 degrees. And then we have to look at what happens if angle B is 130.8 degrees. And we have to solve these as two separate problems. If angle B is 49.2 degrees, we go back to our picture. Remember, angle A, we know that angle A was 46 degrees. So therefore, angle C is going to be 180 minus 46 minus 49.2 degrees. So 180 minus 49.2 minus 46 is 84.8 degrees. Let me just make sure that I did that right. 49.2 plus 46 plus 84.8 Yep, that's 180 degrees. So if angle B is 49.2 degrees, then angle C is 84.8 degrees. And now we can proceed to find side C. If angle B is 130.8 degrees, we know that angle A is 46 degrees. So therefore, angle C would be 180 minus 46 minus 130.8. And that's going to give me about like 2 degrees. Let's do that. 180 minus 46 minus 130.8. We're going to get 3.2 degrees. So we have two really different scenarios here. So we know A is 46. We know that B is 49.2. And when B is 49.2, that gives me my third angle of 84.8. Or the other case is B, maybe 130.8 degrees. Thus, angle A is always 46, but then C would be 3.6. All right, so now we have to find side C. So we know I'm going to use A over the sine of A is equal to C over the sine of C. So I have A was 19 all over the sine of 46 degrees equals C over the sine of 84.8 degrees. And then we can solve for C. C is equal to 19 times the sine of 84.8 degrees all over the sine of 46 degrees. And we approximate that on our calculator. We get C to be equal to 19 times the sine of 84.8 degrees. I'm going to find that. And then I'm going to divide this by the sine of 46 degrees. And I get C to be about equal to 26.3 units long. So that's one case, one solution. And now let's do the other solution. A over the sine of A equals C over the sine of C. So we have 19 over the sine of 46 is equal to C over the sine of 3.2 degrees. So C is equal to 19 times the sine of 3.2 degrees all over the sine of 46 degrees. And in this case, if C is only 3.2 degrees, we're going to have 19 times the sine of 3.2 degrees divided by the sine of 46 degrees. And we're going to get C to be 1.47 units long. This was two, if I round that to 2 places also. All right, so this would be a 2-solution case. So this would be a 2-solution case. So therefore we would have 2 solutions. So we know we were given angle A was 46 degrees, side A was 19, and little b was 20. Solution 1. If we do this and we use angle B to be 49.2 degrees, then angle C would be 84.8 degrees, and little c would be 26.3. Solution 2, if we use the other angle B, because 130.8 degrees has the same sign as 49.2, we get angle C to be equal to just a little tiny angle, 3.2 degrees, and little c would only be 1.47 units long. Woo! So we just saw 2 angle side-side triangles. One gave us no solution, and this one gave us 2 solutions. So you may be thinking, well, how do I know if there is one solution or two solutions? The no solution case is clear because when you go back here and you use the inverse sine button, your calculator is going to tell you there's an error. What you're taking the inverse sine of must be less than 1. If this is not less than 1, it's going to give you an error, and that's the no solution case. If this is less than 1 and it spits out an angle, you're going to use that angle, and then you're going to use the angle, actually it's the supplementary angle, because the sum of 49.2 and 130.8 degrees is equal to 180. So you're going to find the angle in quadrant 2 that has the same reference angle, and then you're going to look at both of those cases. And when we do that, we find angle C, and we get C. So what would the one solution case look like? How would we know if we actually have two solutions or just one? Well, again, it becomes obvious when you're working through the problem. So you're asked to solve the triangle 48 degrees, A is 10, and B is equal to 8. So let's see, where are we here? Yeah. All right, so I'm going to draw this out to the best of my ability. And your drawing doesn't have to be accurate, but it does kind of help you get a perspective of what's going on. So angle A, 48 degrees, is going to be about this. I don't know, it might look something like this. Two sides are pretty close. So I'm going to call this 48 degrees. We know side A, so we know that this side has to be 10. It's always given, if you're given an angle and a side with the same letter, one is capital, one is not. We always assume that they're sides opposite of each other. So then I'm going to call this, let's call this side 8. So in that case, this would have to be angle B. This would be angle C. And we don't know little c. So notice we have a side, and an angle. It's the non-included angle. So we can call this a side-side angle or an angle side-side triangle. Again, focus on this. I know it's silly, but I always say don't let this triangle make an ass out of you. There's 3 things that could happen here. The only situation where 3 things may happen. All right, so we have an angle. So this is going to be angle A. This would be side A. So the only other thing we know is side B. So we're looking for angle B. So I'm going to use the sine of A over little a is equal to the sine of B over little b, which is the sine of C over little c. So we know the sine of 48 degrees. We're going to proceed the same way. Over 10 must equal the sine of B all over little b, which is 8, which is equal to the sine of C over C. Again, we have to use these 2 ratios and solve for B, because we can't use these 2. We'd have 2 unknowns in one equation. Here we would have, if we use these 2, we'd have 3 unknowns in one equation. So let's go forth with this and see what happens here. And again, if you do it correctly and you do this enough, it becomes obvious if we're in the no solution, one solution, or 2 solution case. So sine of B over 8 is equal to the sine of 48 over 10. Bring that 8 over to this side. The sine of B is equal to the sine of 48 degrees all over 10 times 8. Now I'm just going to pop this into my calculator to make sure that we can even do this. So the sine of 48 divided by 10 times 8. All right, so this is about 0.59-ish. So I know this is going to work. And angle B is going to, because 0.59 is less than 1, so I can take the inverse sine of the right side, the inverse sine of the sine of 48 degrees all over 10 times 8. And I get angle B to be about equal to, so there's that number I already calculated, the sine of 48 divided by 10 times 8. So I'm going to do inverse sine. I'm going to do second answer, let my calculator carry it to all those places to be most accurate. And I'm going to get B to be 36.5 degrees. All right, so angle B can be 36.5. Remember, this is an ASS triangle, so we don't want this to to fool us. So we are going to say angle B can equal 36.5 degrees, or angle B can equal, well, we're looking for the angle in the second quadrant that has the same sign as 36.5 degrees. So in other words, we're looking for the angle that is supplementary to 36.5 degrees. So 180 minus 36.5 is equal to, subtract 143.5. All right, so what we have here now is we have two scenarios. Angle B can either be 36.5 or, so therefore we know we have two situations. So angle B is 36.5 degrees. And then we have our other situation. Angle B could be 143.5 degrees because both 36.5 and 143.5 both have sine equal to about 0.59-ish. All right, let's remind ourselves what we know. We know angle A is 48 degrees and side A was 10. So therefore, angle C in this case would be 180 minus 48 minus 36.5. So 180 minus 48 minus 36.5, it's going to give me 95.5 degrees. So if angle B is 36.5 when angle A is 48 degrees, then angle C is going to be 95.5. So we're going to proceed and solve this. Now over here, we know that angle A is 48 degrees, little a is 10 degrees. So since angle A is 48, we're going to test the case if B is 143.5. Angle C would be 180 minus 48 minus 143.5 degrees. And we get 180 minus 48 minus 143.5. We get C to be negative 11.5 degrees. All right. Angles inside of a triangle cannot be negative. So that's right here. In the last case, we didn't get C to be negative. We got an angle that made sense, so we proceeded with the second solution. Here, B can either be 36.5 or 143.5 degrees. If we assign 36.5 to B, C can be 95. C will be 95.5 degrees. If we assign 143.5 degrees, C will be negative 11. So this is not possible. Not possible. And we have the one solution case here. So now we just have to finish this up, the one solution case. So we're going to go with this. We don't have to worry about this. We have the one solution case. And we finish with that one solution. So now we have the sine of A. I'm going to do A over the sine of A equals C over the sine of C. So A is 10. Angle is 48 degrees. And that's going to equal side C over the sine of 95.5 degrees. So C is equal to, well, actually it's about equal to because that's an approximation, 10 sine of 95.5 degrees all over the sine of 48 degrees. And then we're going to use this in our calculator. We're going to do 10 sine of 95.5, and we divide it by the sine of 48 degrees, and we get about 13.39. So therefore, our one solution we knew angle A was 48 degrees. We knew angle B. Nope, we didn't know angle B. We only knew angle A. We knew side A was 10 and little b was 8. And then we found angle B. The only angle that worked was 36.5 degrees. From that, we got angle C was 95.5 degrees. C, sorry. And little c was about equal to 13.39. Whew. So again, be careful Be super careful with the side-side angle, angle, side-side case. You may get one solution, you may get no solutions, you may get two solutions. All right, 8.1 to do. Read 8.1. Exercises 7 to 43 odd. C to do in Blackboard for Alex percent 448. I haven't looked at that yet, so it's going to take me a minute to look that up. All right, kids, lots of problems. It's the only way you get good. If you're struggling with any of them, I'll be more than happy to go over these via Blackboard. I can even post more upon request if you want to see a couple more examples. All right, hope everyone's doing well. Don't forget to do that little one question test to make sure you have both the lockdown browser and the responses webcam, okay? Talk to you soon. Bye.